Hello, everyone, and welcome back to this little series on data visualization in R. My name is Sophia, and today we're going to be talking about the third type of bivariate graph that I mentioned last time. So in the last two videos, we talked about comparing two categorical variables, comparing two quantitative variables, and today we're going to talk about comparing a categorical variable to a quantitative variable. Which is a very common type of graph. A lot of these will be pretty familiar to you. So let's get into it. So for the last two videos, we've been using data about makeup shades, but today we're going to mix it up. This is actually the latest data set to come out at the time of recording from the Tidy Tuesday database. So this data is just, well, it's not just, but it's a little more basic, I'd say, than the last ones we've been working with. It's just about incomes. It's collected from a survey that I believe anyone could take. So it's like self-selected responses. As we'll see, we'll run into some issues that come up from that pretty quickly, but it's just a survey. There's a lot of data points here. It's 24,000 plus, so a lot of people responded, but you can't really claim this is like a random sample. But yeah, let's take a look at some of the things in this data. Pretty standard survey questions. People were asked their job title, their industry, their age, like their income, their location, years of experience, gender, race. Yeah. So actually for this video, I'm not going to be writing all the code from scratch like I have been. I'm just going to be, I wrote like all the code ahead of time, and I'm going to be going through it because I ended up with like more than 200 lines of code, and it would be a little bit excruciating to write all that out again. So I'm going to just go through this. I'm not going to go over like every single like thing I'm writing out, but hopefully it'll make sense anyway. So I'm just loading in. Again, I got this from the website, just like we did before. And we can take a look. And we have some of the same stuff come up. Okay, let me get rid of this. This is spoilers for next video. There we go. Now we're set. So we have survey. That's the data we just loaded in, and we can see same variables that we just talked about. All right, so the first type of graph that we're going to talk about is a bar chart. And actually, I'd like to, before we start, doing all this, I'm going to say that today, there's not going to be a lot of like subsetting, filtering. We're just going to do that once pretty much. And then basically, we're going to graph the same data just in different ways. So it's going to be very similar, like visualization, well, not similar visualizations, but similar visualizations of the same data, just different ways of visualizing it. So I'm just going to like go through these charts like 1, 2, 3, 4, 5. We're starting off with a bar chart, which everyone has seen for sure. Some of these are going to be a bit more strange. But most people think of a bar chart and they think like this type of bar chart, because we talked about bar plots in the first video where we were comparing two categorical variables because we had like multiple bars in the same category and we were comparing their heights. And now we're just gonna have like some distinct bars going up to a certain height, and that height is going to be associated with like a clear number, and we're going to be like worried about that number and not really like putting those bars next to each other on top of each other like we did before. But yeah, first we do have to do at least a little bit of filtering from this data. So let's open up our diffler library and let's just filter out a few industries right now. So let's say I want to compare the average annual income, because annual salary is given here. And I want to see like what's the average salary for these industries. And I just picked out 3 that were pretty common in this list. There are tons, as you can see already. There's all sorts of industries, but I just picked out 3 of the common ones: law, education and higher education, and healthcare. So some kind of basic industries. And now we just filtered out. We took those 3 industries and made them into their own little table. So now you see it's just those 3. All right, now we're going to calculate the mean annual salary for each industry. This is very similar to what we've been doing before. We've done this in like every video, I think. The one thing that's different is this little symbol here, which doesn't really change anything. It's just a way of condensing your code. So what this means is, instead of saying like, we're going to plot data, new survey, like group by industry, and then we'll save that to this again, and then we'll run a new line of code where we have plot data gets like the summarize of all this. And so normally we'd have to run like 2 or 3 lines of code, which we do kind of, but we don't have to keep saving it to the same variable, because what this little symbol does, the percent arrow percent, oh whoops, move that around on accident. What that does is sort of input whatever we get out here into our next thing here. So here we've grouped by industry, and without like stopping, we're just going to put these like grouped things right into here where we're going to summarize them, and then we're going to store them in plot data. So it's just a way of condensing code where you don't have to like keep writing out this first part where we're, assigning something to a variable. Yeah, but this should all look familiar if you've been watching the previous videos. We run that. Oh, something is wrong. We want to calculate it for each industry. So why did we give just one value? Mean, summarize, group by industry. Well, let's do these first 2. And now let's run this. Okay, sorry about that little pause that happened. You know what? I wrote everything correctly, but as I was writing code for either this video or the next video, I was messing around with some other packages that overrode some of these methods, and so things got kind of messed up. But it's working now. If that sort of thing ever happens to you, I think it's pretty common. Just close out and then go back in, and then you can just reload this library, because sometimes things depend on like what order you load these libraries in. So we just got a nice reset. Things are working now. And now we have kind of what I was intending to get, which is 3 summary statistics, 1 for each industry, because we remember first we filtered out all but 3 of the industries, and then we found the mean like summary statistics for salary. Yeah, and now load in this again, ggplot. We've been using this a lot. We're going to be using it throughout this video again. And there we go. We get our bar graph with summary statistics. As you can see, a pretty similar format. I think we did this in the last video, or the second to last video. Just instead of multiple bars, we have 1 bar, so 1 set of data. But you might be noticing, like, if we actually pay attention to what's going on, it looks a little weird. Education has an average income of, what is that? Like 500,000, which does more than 500,000, which does not seem right. Even for like higher education, like academia, like that doesn't seem right. So something's going on here, and we know that income data isn't. We usually use medians for incomes. I'm using means here as like an example, but we usually use medians, right? But still, even with means, they're not usually this high. So let's go take a look at like the actual data. And when I first did this, I was like struggling with this. I was like, what is going on? But I went and I was like, okay, we can go and sort by annual salary and see like what teacher is earning this much money. Actually, we can just go into the original like survey data. And we have these options in R where we can just look at the data, sort from highest to low, and okay. So we see, then these are individual like entries. We see that somewhere there's an old white woman who works in higher education, who is earning $870 billion with a $120 billion bonus. Yeah, so that's why our mean is this high. And I guess this is the problem with like surveys where anyone can submit a response. Like clearly, I don't think this, I mean, this probably wasn't like something malicious, and maybe it was like, well, my theory here is it was a problem with like the conversion, like maybe they didn't convert to dollars before they put their salary in, so they were operating under like another currency, which is why it's so high. I don't know what the Indonesian currency like conversion is, but clearly this is like not at all accurate. And we can see that we have several of these, you know, some not as egregious as others, but still these are not all these, there's no way these are like actual incomes, at least for normal people, for like voice actors. And so we should probably have some like cut. We can't know like out of all of these data points, like which ones are genuine and real and which ones aren't, but we can state like some cutoff. So let's say like, you know, 5 million is going to be the cutoff, because yes, people earn more than 5 million, maybe even some people on this list, but if we cut those like super duper high values off, this is going to look more like, it's going to be a more accurate portrayal of the mean, you know. So let's do that. I'm just curious, we're down here, for example. Here we're still in the, I feel like some of these really high values were mistakes with like conversion. So, you know, let's get rid of outliers. Let's do that. And again, I'm just going to do another disclaimer. I've done one of these, I think, in every video, but some of the things I'm doing here may not be like statistically super good ideas, you know, like just getting rid of a bunch of data because you're like, those seem like outliers. But I'm really focusing on data visualization here, and I want this to be as accurate as possible without like spending too much time worrying about like, oh, like, is this accurate? This data isn't really going anywhere. I'm not analyzing it for someone, so we can do this. And yeah, this I did that for the whole survey. Now we just redo these little filtering things we did so that our subset adheres to the same thing. Do that again, and now let's graph this again. Yeah, so to me, this seems way more reasonable. Like a mean of about 75,000 for higher education. Healthcare is a mean like a bit higher than 90,000. Law, closer to 120,000. This seems like a very average progression of average incomes, annual incomes. So, you know, we've made a pretty simple bar graph here. Here I messed around a little bit, and we can do it so it looks a little better. It's not just these little gray columns. Oh, another. Yeah, so I don't know. Okay, this is the problem. Right, here's another library scales. Let's try that again. I'm having a lot of problems with libraries lately. Okay, so here we have hopefully a little, I don't know if the color is a good choice, but another bar plot with nicer labels. You know, each of these values has an exact label, which is nice. Here we've added little dollar signs, which I think is a convenient feature here where we can say label equals and then just put a dollar sign in front of all of these. yeah, put a nice title to the graph. So this looks pretty nice. It gives us like a fair amount of information about these three industries if we were just curious about comparing their annual incomes. Yeah, so, and just like that, let's move on to the next. We're moving pretty quickly in this one. The next type of bivariate graph, right? The next one is called a grouped kernel density plot. And before we get started graphing it, it might be a good idea to get an idea of what it's supposed to look like. And that'll make the actual process make more sense. So just go, yeah. So you've seen these for sure. This is what it's called. They're called kernel density plots because they show like a density of some variable. And you can see why this is the specific one we're talking about in this video. We have categorical variables here, but also quantitative variables like on the x-axis. Yeah, so let's go back here. And we're going to be graphing, again, salaries grouped by industry, except now instead of just one summary statistic, we'll have more of an idea of like the shape of each distribution of salaries. So again, we're using the ggplot function. Okay, yeah, so this is a correct plot. But again, the thing with incomes is we have a bunch of these like weird little outliers where they're not really contributing to like a density plot, they're just there. So I'm going to scale these more correctly. And as I was looking before, I think 30,000 was a pretty good cutoff for like, we don't want to like cut off anything important, but we also don't want just a trailing line around 0. So here's I think a better representation where we have our one categorical variable, 3 values of that variable. We have the 3 industries, and we can see sort of the density plot of those in relation to salary. Like for example, we see education is probably overall the lowest, like we saw, has the lowest mean. It's kind of a little lower here, but it's also more narrowed, you know, it doesn't have a big of a range. Whereas like law, you can see there's a lot of area here in this upper part, even it's kind of going off here, where we can see it's more like right skewed. Yeah, maybe it's like its peak isn't that far off, but it has a lot more people on the higher end of the income gradient here. Yeah, and we can now move on to our next one, which are box plots. Again, you've definitely seen these. These are those like, you know, sometimes called box and whisker plots. They're actually pretty good for incomes because they keep track of medians, those like first and third quartiles, things like that. So yeah, as you've probably heard, a median is usually a preferred measure for incomes because it isn't as affected, or I think the right term is it's resistant to outliers, to those like really high earners. We eliminated the like ridiculously high earners, but there's still going to be high earners who skew this like curve, you know. So let's plot this. And I'm going pretty quickly through these, but all of this code is going to be available as usual in the description of this video. So hopefully that will allow you to go back and like look at what I've done here. Here we have again, salary distribution, same data, just plotted in a different way. And actually here, I've already included this like Y limb. Before, when I did it, I first just plotted this. And as you can see, in an effort to display like all the data points, we have these like outliers going really far and we can barely even see the actual box. So I combine that with like this little limit on the y-axis where it just goes from 0 to 250,000. And obviously there's people earning more than 250,000, but this lets us see like really the median and the quartiles and the whiskers of the plot. So yeah, if we look at this, we can kind of see, actually before I do that, never mind, let's talk about this for a second. you can really see like where the medians are at. You can see the medians, just like the means, seem to be kind of growing larger from education to healthcare to law. And just like I mentioned, the density plots, the law seems to have a higher like variability. I guess variability is more of a term with means, but yeah, you know what I'm talking about. It has a bigger range between the bigger interquartile range. It has bigger like spread around the median. Yeah, and as for outliers, we can see all of these have a lot of outliers because we have so many data points that even though this is supposed to be like a small percentage of the data points that are outliers, that's like how they're defined. It turns out just with our massive amount of data points, there's like a lot of outliers. So maybe in a way, this isn't really the best type of plot because outliers should be like outliers and not really just these like long string of dots. But you know, we work with what we have. And all of this, it's up to you when we finish this video, which one of these graphs was the best way of representing the data. But I just want to go through them and show you like what's possible. So the next type is another, it's basically going to be the same thing, but these are called notched box plots. And I'll show you what it looks like first and explain why they're a little different. So obviously I haven't changed much, but I've like colored them and added this like notch equals true parameter. So what that does is make these notched around, you can see there's a little notch near the median. And what that does is give kind of a confidence interval for the median. I don't know if that's exactly what it's doing, like calculating a confidence interval, but that's kind of the way it functions. And what that tells us is if we like compare these and we look at where the notches are, if the notches don't overlap, we can be like really confident. There's probably some percent involved, which isn't included here, but we can be pretty confident that the actual medians don't overlap. And again, with data that's like weirdly like self-reported, and we've already seen there's some weird data points here, we can't be obviously like positive. But the fact that these notches don't overlap indicate that there's a high probability that the true medians also don't overlap. That it really is this sort of progression from higher to lower. Yeah, so I just thought that was another interesting way to look at this data. And moving on to the next type of graph, we have violin plots. So named because they kind of look like violins. And here I'm gonna include already this width limit. We've seen that, you know, we want to keep the y-axis kind of low so we don't have all these like outliers on the top. And you'll see why in a sec, because violin plots resemble these box plots in a lot of ways. Yeah, so instead of like just having like a little box with like a median and whiskers going out both sides, we now have these like kind of violin shapes, kind of not, these graphs that also show a mix kind of between like the median, the spread, and like the density. So this kind of looks like a kernel density plot. It's kind of like the kernel plots we got, just like turned onto their sides and like reflected across an axis. So yeah, and we can kind of draw some of the same conclusions we drew before, like law has more area here at the top at a higher salary, whereas education is like really has a lot of people near its median. And here I'm just kind of graphed them on top of each other. As I was saying, they're pretty similar in structure, these two types of graphs. So we can just kind of slap one on top of the other and get all of the information at the same time, both the medians, the actual distribution, and things like the quartiles, the outliers. Yeah. And what else have I done? I haven't done much. I've just colored them, given it a title. Yeah. Now we can move on to our next type of graph, which is a strip plot. And these are kind of, you notice they kind of look like one-dimensional scatter plots. And you'll see what that means in a sec. So again, let's grab this. So quick interlude, actually. Well, I've been copy and pasting these really quickly, or just running them super quickly. But you've noticed that all of these different plots, I've been doing them in ggplot. So it's not like, I didn't just choose this at the beginning as like, oh, let's just mess around with this random library. Like, this is really useful. And all of this code is actually really similar. Like, if you compare them for all these like all these graphs look really different, but the code for them is like, you just modify little things inside of it. And you can, if you think back to like the scatter plots, the line plots we always start with like the name of the data, where we want the x, what we want the x and y axis to be, and occasionally like what we want the bars to represent. And then we add just geometric objects and labels, and sometimes like limits, and that's it. So here we're adding Geon points again. If you remember, that's actually the exact same command we used when we were making scatter plots. Just here, they end up on one dimension because we just have these 3 categorical variables instead of having another quantitative axis on the y-axis. Whereas here we use things like, we have violin geometric objects, box plot geometric objects, bar density objects for kernel density plots. But other than that, if you go back and take a look at all this, you can see that all of this code looks really similar from one graph to the next. So it may look like really intimidating, but actually when I was writing this, it wasn't too difficult, because I just had to find out like, okay, what is this new command that we have to incorporate? Or in some cases, just an old command that we have to incorporate in a different way. But basically we end up with things that are pretty similar. So yeah, let's take a look at this, this strip plot, as we have just strips of these points. And we can see that, personally, this is probably like much better for graphs where we don't have a lot of data points, because then we could, like, if we ignore that this part exists, we would just have, we could compare these pretty easily. We can see, 2 here, 2 here. And we can compare things like spread. Yeah, and if we don't have enough data plots to make a density plot, this might be a really good idea. But as you can see, we end up just having these like massive groups of dots where the information we can get from this is kind of limited. But there is one thing we can do to make it a little better, which is it's called jittering, which is where, I kind of think of it like if you hold a plate and you have like a thin layer of rice, and you shake that plate, the rice is going to get a little spread out. So we're going to jitter this like plot and let these dots spread out a bit. So we did this with this Geon jitter object, or command, which is just going to add a random small y value to each of these points. So the points might stay around the same, they might go up a little, might go down a little, and we'll end up with them spread out. So let's do that. Oops, sorry. There we go. Yeah, so, still have kind of a big cloud of these black points, but it is a little easier to see maybe around the edges what's going on. Or actually might be harder, because now we have like just groups of points that look more like a scatter plot than like individual groups of points. But it might help if we, instead of having all this empty space, we just focused in on like this part of the graph where things are really condensed, and let things spread out more through, just getting a little closer. So basically what I'm talking about is we're going to restrict the x-axis to just 500,000 as the max, where we're going to ignore these like few points at the top, and instead hopefully we can get an even clearer picture of what's going on in the majority of this graph. yeah, so now actually we can see this is thinning out a bit. These are still pretty dense, but you know, I personally wouldn't find these very helpful, but as I was saying, these are a lot more useful if you have a limited number of points. But I wanted to go along with like the same theme of using the same data, and you can kind of see how this works. And even now, we can kind of see what we were talking about, where law has things more spread out. We don't have this like big cloud near the median like we do, especially here in higher education, where it's just a black mass. There are no gaps in the dots. Yeah, so the next type of plot is the B-swarm plot, which is kind of like a mix between a violin plot and a jittered scatter plot. And again, I said this isn't that helpful for us because again, I believe that we have a little too many data points to really rely on these types of graphs. But you know, it's a cool type. These are all like cool types of graphs, and I encourage you to experiment with them in different data sets. And I'm sure that they all have their uses in certain contexts, just maybe not in this context. But here, I'm just going to run this library and put in this code. Yeah, so if we take a look at this data, this graph, this looks really similar to what we have with Violin Plot. So the reason I said, you know, this isn't very helpful is that we're not getting a lot more information with this than what we got with the Violin Plot alone. You know, we get a few data points, individual like outliers. We can see those individual outliers instead of just having a line. But, you know, it's basically the same as just having a filled in Violin Plot where all of these are just different colors. Because of again, like the sheer like number of data points that we have. So actually I was thinking, and maybe like instead of having a smaller data set, we could, or like a smaller sample size, we could just like randomly sample from within this sample, if that makes sense. Like this wasn't a random sample, but we could take like a random sample and graph those points. And that might help us get like a little clearer picture of what's going on, even though I'm not sure if that's like allowed statistically, just like taking a random sample if the original wasn't a random sample. But I think that might make this type of graph a little more useful to us. But before I move on to the next one, I just wanted to point out a few stylistical things that I did here, particularly these theme commands. So I might have been using these already, although I don't think I was really. I was mostly doing colors manually. But what this theme does is it's sort of an easy way of making your graphs look nice. And these themes don't just apply to this type of graph. I think you can use themes for all types of graphs. But for example, this like theme minimal, that's what made our background like nice and white. If you notice, like a lot of the graphs have like a weird like gray background, like all of them actually. But if you use this like minimal theme, they'll have a nice white background. I think everyone agrees that kind of looks nicer. And you know, it gives you like the default like red, green, blue colors. And there are other themes you can use that'll make your graphs look nice. They'll give you like different color schemes. Yeah, it's just kind of a shortcut to making graphs look pleasing to the eye, which is one of the main goals of data visualization. It's like obviously it's important for the data to be useful, but we also want it to be like nice to look at. Yeah, and so I'm going to move on to this next type of plot, which is a mean-SEM plot. And we're going to add sort of another variable here. So it's not technically going to be a bivariate graph anymore. But you'll see we're going to be doing it in a way where it's bivariate like plus another categorical variable. So I guess we're really going to be comparing two categorical variables to one quantitative variable, since we're adding gender. Yeah, the first step is we want to just like go over this data, this raw data, and just calculate the means, the standard deviations, the standard errors, and a 95% confidence interval by rank. And that is because this particular type of graph operates on this SE and SEM the SEM stands for standard error of the mean, because these plots are the type that, they show the mean and they have like a range given for the mean where like kind of like, again, like a confidence interval. But the way we calculate those like intervals, those standard errors for the mean differ. So we might choose to use like standard deviations, we might choose to use standard errors, or we might choose to use a confidence interval. Probably not all three at once. I think in this case, I'm going to be using the standard error, but you can experiment and see like what comes out. So first, I'm just going to calculate these. I'm not going to go super in depth, but you can kind of see how we're doing. There's actually some convenient commands for like finding the standard deviation. Here's just an equation for standard error, and again, we have some like methods that help us find the confidence interval, or rather let me find this is plot data, or rather the width of the confidence interval, because you can see it doesn't really give you an interval, it gives you like, I think it's half of the sort of width of the interval. So it's like the mean plus or minus like these values. And this n is, of course, the number of points we have in each of these three categories, which we sort of labeled here and which were useful, which were necessary for us when we were finding these different statistics. So now let's just plot the mean and plot it with the standard error of the mean. So this is what I was talking about in this little interval, where kind of like when we made a plot of our, kind of like when we had bar graphs, when we plotted our bar graphs, these points are representing summary statistics. So they're not representing any one point. They're just showing us the means as they go up here. And these intervals are representing the kind of range that the mean is probably, the true mean is probably in. Or here it's just a standard error where we're showing like, the typical range that this mean would be in. Yeah, so again, this is showing the same types of things we've been seeing again and again in the data where, okay, same trend for which ones have a higher average, same trend even in this like range where we've seen law has a higher variability in the data, and education is much more condensed. It's much more condensed around the mean. Yeah. And again, once more, ggplot, using the geom underscore error bar as our object this time, where we're giving it, this value of SE as the standard error, and we're telling it, for y min, make it mean minus that, y max is mean plus that, and we end up with this like interval. And now we're gonna add, so here I had gender, down here I have race. I think we're gonna be adding race, yeah. And as like another variable where instead of one line, we're gonna have multiple lines and each one is gonna signify like a different race. So they're all gonna be summary statistics. They're just now gonna be even more specific than just one summary statistic per industry. And just run this data at first, which is pretty similar. Run this code, which is pretty similar to what we did before, where I'm saving this to plot data 2, and we can take a look at that. And yeah, we've just saved the industries, the race, and the number of like points in each of these, and the summary statistics. And after that, we can just, I was gonna say, let's just try graphing that first before I start setting. Yeah, so we end up with kind of this mess where we can't even really see the graph, because there are so many like people were like self-reporting their race in this survey, which is good, obviously, but we can see we have a lot of people, well, not a lot of people, we have a lot of like categories where there's just one or two people, and then mostly, mixed race categories. And, we can have conversations. Obviously, those people shouldn't be excluded. But for us right now, we can't really like summarize each of those in a line because there's just one point. That kind of defeats the point of having a summary statistic like the mean. So yeah, instead of doing that, let's focus in on like just a few races, and ignore the rest for now, even though obviously it's important to look at all of them if we were actually worried about like representing this data in like a very helpful way. But for now, we don't have a lot of space in our plot. We just want to plot like say 4 different race groups. And now let's run this code again. Yeah, and now we end up with a little bit, it's still kind of a messy graph, but we can see kind of what's going on. We can choose one of these colors and kind of follow through with it through the graph. And we see we have the same line structure that we had before, where it's hitting these 3 industries. We have a standard error kind of bracket around each mean, and we have one of these lines for each race group. But one thing that's a little annoying about this graph is that the error bars overlap. So we end up just having like this kind of mess of error bars. This graph would obviously be neater if we just had like a line plot for each of them, but part of what makes it interesting is this error plot. So one thing we can do is kind of make it so they don't overlap with this dodged, but it's called dodging. And we did something similar when we actually graphed our bar plots 2 videos ago, where instead of having them stacked on top of each other, we had the bars dodge each other, where they were like one after another, side to side. So let's just run that. Here we assign like a position where we say dodge each other, and then we graph it again with that position in mind. Yeah, so to be honest, it like doesn't help a whole lot, but a little clearer we can see if I want to say like, oh, like what is the range for the purple dots here? I can kind of see, okay, it's this little small bracket here, green is here. Whereas before, I think that would have been like really lost when they were just all on top of each other. But again, it's up to you to decide. I'm just showing the options here. So yeah, here we've sort of added another categorical variable that we were interested in, and ended up with, I guess, a multivariate graph instead of just a bivariate graph. So that's pretty cool. And now I'm going to show just one more type of graph. We've covered a lot, but in this one in particular has the ability to include more than just 3 industries. And obviously for all of those above, we could have had like a bunch of industries, but it would be harder to focus on a whole lot because we already have like so much information going on, that if we had a lot of industries, it would just make the graph look really crowded, really hard to read, and not very nice to look at. But Ridgeline plots, I guess I'll show an example so you can kind of see why we're choosing to use more values of the categorical variable. Yeah, so they look something like this. And as you can see, a lot of these have like a lot of different values, because it's kind of slimmed down from actually, it's like the opposite of slimmed down. It's like a stretched out version of the kernel density plot, where instead of having these all stacked in like 2 dimensions, now they almost look kind of 3-dimensional, where we have them going on like a z-axis sort of thing, or a y axis. where you can really contrast them, where if all of these were like on top of each other, it would just be a mess of color. We wouldn't really know what's going on. But before we graph that, let's pick out some more industries, or rather I'm going to pick out some more industries from the ones that were popular. Not a whole lot of like big reasoning as to why I picked these. They're just some of the more popular ones. They have a lot of data points associated with them. So now we have, let's see, how many different industries? I'm not sure, but 1, 2, 3, 4, 5, 6, 7 different industries. You could probably do more, you could do less, but 7, lucky number and all that. Let's go with that. And now we run this GG Ridges library, which is going to allow us to construct a ridgeline plot. And again, I've been saying, I know I'm repeating myself, but it's a lot of the code is just the same thing we've been doing. We're going to add a theme. We're going to have our limit on the x-axis so that just like with the kernel density plot, we don't have long lines extending to the end of our graph. But instead of just geom underscore density, which is what we had with the kernel density plot, we're going to add underscore ridges to show that this is going to be a ridgeline plot. So we run this and we get this, I think it's a really nice looking graph, similar to what we saw over there in Google Images, where we have density plots for each of these industries. And we can really compare like the different shapes that these density graphs take on without having it be very overwhelming. So yeah, if we take a look, we can see a lot of them have kind of similar shapes, but some of them are more skewed to the right than others. We know income is always skewed to the right, but here we can really compare like to what degree that happens. Again, in law, I've been saying this again and again, but just something consistent that we can see from this data is that law is very skewed towards the right. Whereas education, really, it looks pretty normal. Like, and it still obviously has this little tail going off, but if you like cut this out, it would almost look like a, well, not normal, but a symmetrical, I should be saying a symmetrical density plot. Yeah, so I think that's about all we're going to do in this video, but hopefully that was kind of helpful to take a look at the different options you have for this type of bivariate plot. And of course, all of this depends on the context, depends on what data you're using. I just chose these particular variables since I was looking for one like categorical, one quantitative. I ended up going with salary and with occupation. But you can use combinations of these different bivariate plots. You might have like a scatter plot on one side where you maybe have like years of experience and like income or salary, and you might have like one of these on these other where you're comparing occupation and salary. So really the beauty of statistics and of data analysis is the ability to like pick and choose what you want to do and like try different things and see what looks nice. We've seen some of these like didn't look nice at all, and some of them I think look quite nice and give us more information than others. So yeah, just explore. This was a lot of code. Again, I'm gonna post it all in the description and you can kind of experiment and see what you think. So thanks for watching and I'll see you in the next one. Bye.